Hello and welcome to Chicago Reacts. My name is Lauren and today I am going to be looking at a video by Real Engineering. This is the questionable engineering of Oceangate. So I just recently watched a couple of videos about the Titan sub. New information has come out. And it's been coming out, which is very interesting to me. And it seems like it's interesting to you all as well. And so people suggested that I look at the Real Engineering video, talking about, just why some of these things that they did were so bad. Kit is also watching some videos about this, but we're posting most of those on the other channel on Americans Learn. So if you want to see different sides of the story, different videos, you can go ahead and check out those. But like I said, this one was suggested to me that I look at the Real Engineering video. And I am very much looking forward to finding out why, like, specifically why these things are wrong. Because, like, several of the videos I've seen recently have talked about how things were not done, like, that things were bad. But they were a little light on some of the very specific details about the whys and wherefores. So, hopefully Real Engineering will give me the answers to those questions. Let's go!
On the 19th of June, the Oceangate submersible began its descent to the Titanic's fractured remains here in the northwestern Atlantic. With a descent rate of 55 meters per minute, it would take the submersible 70 minutes to reach its destination. With each passing minute, the equivalent of 5.3 atmospheres of pressure would be added to the sub's hull. By the time it reached its target depth, the weight of 366 of Earth's atmospheres would be attempting to crush it.
Wow.
Applied to an area a little larger than an A3 piece of paper. That's equivalent to the thrust of a Saturn V F1 engine, pressing in from all directions. An hour and 45 minutes into the dive, at the bottom of the ocean, 3,800 meters down, with this immense pressure bearing down on its hull, the Oceangate submersible lost contact with the surface. We now know the submersible imploded, a sudden catastrophic collapse, a tragic accident. However, any composite material engineer could have predicted this failure, and they did.
I'm glad that he is, like, that in this video it is confirming that there was an implosion. I've just seen so many, like, clickbait titles and stuff on YouTube that's like, everything we know has changed, and it's like a no implosion and question marks, and I'm like, I haven't clicked on those videos. But I was just like, but no, I feel like it was still an implosion just because, like, it, just because the tail of it or whatever, didn't, like, get crushed into a little ball. People are like, it didn't implode. So I'm glad we've got confirmation to start.
I worked as a composite design engineer and completed my master thesis in composite failure prediction.
Oh, wow.
So
okay,
let's
cool.
dive into the questionable engineering decisions that Oceangate made that led to a tragic accident.
Also, good
With that pressure
credentials.
comes some extreme design challenges. Oceangate's Titan submersible consists of two titanium end caps, one with a large acrylic window, joined to a filament-wound carbon fiber reinforced epoxy hull. Inside the submersible is pretty bare-bone. Some screens that are fed data from cameras from the outside, and the 4 electric thrusters are controlled with, from what I can tell, a third-party GameCube controller. Many people are focusing on this part of the design, but that's the least of my concerns. We will be
That's what a lot of people have been saying. I was like, really, game controller? But like I got a bunch of comments about that. It's like, that's actually probably okay. It's like, oh, okay, cool. Great.
Focusing on one design aspect of this submersible, the composite hull. Carbon fiber composites aren't really known for their compressive strength. They work best in tension. Great for aeroplanes that are pressurized from the inside, where the pressure inside the fuselage works to expand the circular cross-section, putting the fibers in tension. For a submarine, the pressure will work to compress the hull, placing the fibers primarily in compression. This immediately set off alarm bells in my mind when I heard of the missing submarine, so I began digging into their justification for using the material.
Okay, so he's saying that the carbon fiber works better for if it's pressurized inside as opposed to outside. The pressure, because I think, because in, it's, things are thinner where the planes fly. So you have to pressurize the inside of the plane as opposed to a sub where the outside is pressure pushing in. So you need to depressurize the inside. Okay. I'm not sure I fully understand that, but that might just because I'm stupid.
Oceangate chose this carbon fiber composite primarily to benefit from its natural buoyancy. These type of subs actually want to be as close to neutrally buoyant as possible, meaning the weight of water they displace weighs about the same as the vehicle itself, minimizing the energy needed to rise or sink in the water. This means to surface in an emergency, they don't need power, they just drop ballast that make them positively buoyant and they just float to the surface. The carbon fiber composite can be lighter and thus helps achieve this neutral buoyancy target.
That kind of gives like air balloon vibes too, where you just you cut the sandbags to rise, right?
Typically, submarine hulls are made from steel, or more recently, titanium. But in order to achieve the desired buoyancy, they need foam outer layers. Oceangate's CEO, Stockton Rush, who was inside the submersible, stated that they wanted to skip this foam layer because it added to costs. That isn't necessarily an evil thing if the composite is up for the job. This is where things get iffy. Oceangate had no idea whether it was up to the task or not. And we know this because they admit it in their own blog post, justifying their decision to not test the vehicle with a regulatory body. The now removed blog entry reads, "Most marine operators require that chartered vessels are classed by an independent group. Classing assures ship owners, insurers, and regulators that vessels are designed, constructed, and inspected to accept its standards. Classing..."
He's like, I wanted it to be my own thing, and I didn't want any stupid rules lawyers getting on me. It's like, when it's like a TV show, yeah, you want it to stay out of the hands of the producers as much as possible, out of hands of the studio, as much as you can. But when it comes to something that involves safety, there's regulating bodies for a reason. And I've said that multiple times throughout these videos. It's just it just makes me so upset that he was so convinced that he was right, he refused to do proper testing because he didn't want some outside party coming in and telling him that it was not safe.
May be effective at filtering out unsatisfactory designers and builders, but the established standards do little to weed out subpar vessel operators. The vast majority of marine and aviation accidents are a result of operator error, not mechanical failure. As a result, simply focusing on classing the vessel does not address the operational risks.
It helps,
now,
though.
I would have thought this wouldn't need pointing out, but the fact this glaring red flag has been written on their own website for everyone to see, and several extremely wealthy and successful people didn't seem to think it was an issue, seems to suggest otherwise. Perhaps
they always think that they're so smart and they know so much. It's we need to figure out a way to check some people's egos. Some people, the egos just get out of control.
Most submarine accidents occur due to operator error, precisely because they have undergone rigorous testing and certification. The comparison to aviation is just a wild can of worms that
it's a wild can of worms. That's a fun one. I wonder how they're Raven up there, the little worm party. Sorry, now I'm just imagining a little worm rave. I don't know. But yeah, no. So it's sort of like how people be so many head injuries after people started wearing bicycle helmets, or there was so many more injuries after people started wearing seatbelts in cars. And it's yeah, because there were fewer deaths. There were more injuries because fewer people were dying. God, this is why you got to be careful about stats and stuff.
Perhaps most submarine accidents occur due to operator error, precisely because they have undergone rigorous testing and certification. The comparison to aviation is just a wild can of worms that we have very recent catastrophic accidents to compare to, where manufacturers willfully circumvented regulatory procedures. These aren't procedures created as some kind of unnecessary inconvenience to inventors. They are very useful guidelines and testing procedures to prove that you've not missed some catastrophic failure mode in your design, and that's exactly what happened. One failure mode is unique to composite materials in deep sea applications. Some of the first evidence we got for it was in glass fiber reinforced deep sea piping. It's called snap buckling or delamination coupled buckling failure mode. For thin-walled pressure vessels,
That
the failure
sounds
mode
bad.
is simply buckling, where the pressure simply caves the entire wall in. But here, because the wall thickness is so large to deal with the immense pressure of the deep sea, the failure mode gets more complicated. This
course it
failure
does.
mode is characterized by delamination of the internal layer of the pressure vessel. Basically, the inside of the pressure vessel suddenly peels away from the rest of the wall, leading to a catastrophic failure of the overall structure. The exact mechanisms of this failure mode are not entirely well understood, as stated in this 2022 research paper titled "A Review of Structural Failure of Composite Pressure Hulls in Deep Sea." It states in its conclusion, investigations on this subject have remained at theoretical level. There is still very little research in this area in recent years.
Well, that makes sense
So-
too. Like it's like we've only just started to like figure out how to investigate the bottom of the ocean. Like it's such a dangerous place. It's so like stark and like intense, and we know nothing about it. I had to do a project once, and we had to choose an unforgiving environment. Like that was like the main the main difficulty in this project is like you had to set a scene in a very difficult, dangerous, like stark environment, and it could be anything, like any dangerous environment at all, you know, and you had to set a scene there and like talk about the like different types of problems that are going to occur, and we had to build like various devices that would help in such an environment. So like we chose kind of two. We did a double whammy. So we chose the Arctic, but we chose like a underwater well, it was we set it in an underwater prison essentially in the Arctic. So there was a lot of talk about pressure and about temperature and like things, you know, like what happens if the water gets in, and that was like it was lots of stuff like that. So it's like I used to know stuff about this. It's been a while since I did that project. That was in college, but like some of it's kind of coming back to me a little bit.
I am assuming whoever engineered this pressure vessel did at least the same level of research as a YouTuber who wrote a script on the subject in 2 days. They must have at least been aware of this problem. A failure mode like this is going to be exacerbated by gradual damage incurred by cyclical stresses, like those experienced when diving to depths of 4,000 meters and resurfacing again. They have
Right.
done that at least 50 times with this vessel, without ever fatigue testing it.
Right. So that's something that I remember mentioning at one point in the first video I think I watched, but it wasn't brought up again really in the second, that it's like they have no way of knowing how the various tests they had done had affected the vessel structure itself. They were just like, no, it's been fine every time we've gone down. Every time it's gone down, it's been fine. So therefore it'll keep being fine. But they have not done enough tests on it to find out what was going on inside. That I remember them talking about that in the first video.
Per their own admission, they did not undergo industry standard classifications, but they did do their own classification test. One test, stated on that blog post once again.
One test.
A licensed marine surveyor will witness a successful dive to 4,000 meters, inspect the vessel before and after the dive, and provide a statement of fact attesting to the completion of the dive test plan.
Just
That
one
is
test.
simply not adequate.
crazy.
Anything undergoing repeated stress cycles like this needs to be fatigue tested. like the
Yes.
test airplane manufacturers do on wings, where they flex the plane's wings thousands of times on the ground. They designed this thing essentially with computer modeling, with no real-world testing. Composite materials are incredibly difficult to model in computer software. Composite materials are far more complicated than homogeneous materials like steel, where the material properties are the same in all directions and in all regions of the material. Composites are composed
Okay.
of fibers bound together by a matrix material like epoxy. If we were to zoom into a small cross-section of this, we may see something like this. Some fibers, some of them could be touching without any matrix between them, some could be spaced further apart, and there can also be empty voids that the epoxy didn't manage to fill.
Right, okay.
We can simulate a small section like this independently to help analyze some failure modes such as delamination. However, if we want to zoom out and test a larger section, we often need to average the material properties in some way, or else the simulation will take too long to run. My own master thesis tried to combine the two by embedding a fiber and matrix cell within an averaged composite material. There are specialized softwares that can model different fiber orientations, but they are still very much an estimation. You need to back this up with physical testing, something
sense.
Oceangate didn't do. There are more signs of incompetent use of composites. For a critical structure like this, I would very much recommend curing it in an autoclave. That's basically a pressurized oven that helps push those voids I mentioned earlier out of the epoxy resin.
It's just so funny. Like the epoxy itself, like I just in my brain, I'm like, oh, because people use epoxy resin to make like D&D dice. Like you can use epoxy to do something like this, you know? And it's just so it's like I'm thinking something like that. And then it's being used in like giant structures. And I know it can be. It's just like my experience with epoxy does tend to be in like things like dice or like cosplay, things like that. And so it's like it just unnerves me to think that it's being used in a highly pressurized environment. Like,
Autoclaves are expensive, and it can be difficult to find ones large enough to fit something like this, but it's nice to not have air bubbles in a pressure vessel keeping you alive.
yeah, a little
However, an autoclave was not used for this pressure vessel. It was simply bagged and cured, a cheaper alternative. Spencer Composites was commissioned to make—
it's like, dude, he was a billionaire. He could have afforded not to like, I understand sometimes where it's like you're on a shoestring budget because like you do not have the money, right? You want to do the thing, but you don't have the capital. So it's like, all right, so we might have to cut a few corners and take a cheap option here or there. But I'm just like, but he had the means, he had the time, he was not under any kind of constraints, really. And it was just like, no, he was a cheapo.
the composite hull, and their CEO was interviewed back in 2017 in a Composites World article. He seems very aware of the immense design challenge he has been handed, and he does mention that the porosity of the cured pressure vessel was assessed to be less than 1%. Less than 1% voids doesn't exactly inspire confidence. Is it 0.99% or is it 0.001% porosity? That's exactly
And the fact they're
type
just
of defect
eyeballing
that's
it.
going to increase the risk of snap buckling, as voids can be a propagation site for delamination. The blog post goes on to dismiss classification tests as unsuitable for innovative designs, which is complete narcissistic nonsense.
Yup.
This isn't innovative. They have made a pressure vessel from a carbon fiber composite using known manufacturing practices and started charging rich people $250,000 to risk their lives in it. Innovation would be creating that pressure vessel and testing it, figuring out the causes of snap buckling and advancing material science for all mankind.
Yeah,
This
this
is
was a cash
profiteering, not innovation. To eliminate all doubt
Preach.
that this company has willfully ignored safety standards, this court case from 2018 was brought against Oceangate by a former employee who was fired shortly after raising concerns about the composite hull, stating that not enough was done to check for delaminations and voids. Oceangate argued that the technology to check for voids and delaminations in a composite this thick did not exist. And
Well,
instead,
then create it that. Like, then focus on that for a little bit. You need to figure, you're all about innovation? Innovate then. You say the technology to check for safety on this doesn't exist, then make it exist. Figure that out first.
They would use their acoustic monitoring system, which essentially listens for the sounds of fracture to predict failure. But this is what a carbon fiber composite fracture curve looks like. It's a cliff edge, sudden, catastrophic collapse.
Damn.
An acoustic monitoring system like this is akin to setting up a camera to warn you thunder is coming. You will see the lightning before the thunder, but the time between them is minimal. This is pure safety theater. It gets even worse. On one test dive in the Bahamas, a submersible expert could hear the cracking with his own ears and warned Stockton Rush that it was a sign of damage accumulating. Stockton, once again, chose to ignore an expert's advice.
Oh my god. So they purposefully have an auditory warning system. They get some auditory warnings and they're like, but it's not that. Oh my god. Ugh. This man, I'm glad he's died. Sorry. He was told over and over and over again, and some people don't learn. And it's, it is unfortunate that the teenager died. The others, weren't properly, they weren't fully appraised of the situation. They didn't know exactly how dangerous it was gonna be. But I'm glad he can't hurt anybody else. Imagine if this had gone well and then he just had more and more people and he would fit more and more people. How many people could have been killed because of him?
So, this acoustic monitoring system was purely for marketing purposes, to give customers who don't have the engineering background to see through it a false sense of security. I would attribute this to malice and greed, but Stockton Rush chose to pilot this death trap himself. As Hanlon's razor goes, never attribute to malice that which can be attributed to stupidity.
It's pure ego is what it was for him. I think greed, yes, for sure. But also he wanted to make his name. He wanted to leave a legacy. Yeah, it was no, I don't think he was purposefully trying to hurt people, because if he was hurting people, he's not making money, but nah. He thought he knew better than everybody else. He fucked around, he found out.
There is a growing trend in engineering of moving fast and breaking stuff, mostly driven by one overconfident CEO who has, to be fair to him, succeeded in revolutionizing an entire industry with that ethos. That incriminating blog post even mentions SpaceX, Blue Origin, and Virgin Galactic as bastions of innovation for this move fast and break things mantra. Virgin Galactic too have blood on their hands, with their 2014 in-flight breakup, which was attributed to inadequate design safeguards and poor pilot training, along with the lack of oversight from regulatory bodies.
Again, lack of oversight from regulatory bodies. It's sometimes there for a reason. Also, I'm pretty sure in this Oceangate thing, they used cast-offs from freaking Boeing. And it's dude, if even Boeing doesn't want it, why do you think it's gonna be good?
Attitude is dangerous, and this won't be the last story of wealthy, narcissistic CEOs putting lives at risk. When a doctor is negligent to the safety of their patients, they are liable for malpractice. But the impact their incompetence has can affect one patient. When an engineer neglects their responsibilities, it can affect hundreds, thousands, maybe even millions. We need more people like David Lockridge, the employee who was fired for raising concerns over safety. The very first video on this channel stated our mission: to inspire the next generation of engineers. But it's about more than just inspiring engineers. We need engineers going into the most impactful industries to solve the largest problems facing our civilization. You've probably heard a lot of career advice. Follow your passion, do what you love, take initiative. But a lot of advice out there doesn't take into account the best available evidence we have for what actually makes for a high impact and fulfilling career. Today's sponsor, 80,000 Hours, is a non-profit that, for the last 10 years, has been researching the question of how you can find a fulfilling career that does good too.
Cool.
Everything they publish is based on careful consideration of the data, consultation with experts, and taking into account the best evidence they could find on the topic. And because they take this evidence-based approach, they are able to make concrete recommendations on hard questions like, where should I work if I actually want to make a positive difference in the world? What are the most pressing problems facing humanity today, and how might we solve them? And what can I do today to start planning a fulfilling career? They have
Cool.
published over 30 articles on one incredibly pressing issue: safety in the development of AI. They have a website with tons of collected research on high-impact careers, a job board which lists currently open roles they think might help you have a positive impact, and a podcast where they have conversations with experts about the world's most pressing problems. Everything they provide is free, forever, because they're a non-profit. Their only aim is to help solve global problems by helping people find the most impactful careers they can. If you join the newsletter now, you'll get a free copy of their in-depth research-led career guide sent to your inbox. Just sign up to 80,000hours.org/real engineering or click on the button on screen right now.
Okay. Cool. I did like that video, and I know I get a little mean about Stockton Rush, but like, it just makes me so angry when he got people killed because of his own ego, and it just infuriates me. So anyway, thank you so much for watching. Thanks for suggesting the Real Engineering video. If you want to see more stuff from them, go ahead and let me know, and I will do that because that was very interesting. And I enjoyed it. So thanks for watching. I'll see you all in the next one. Don't forget to hit that like button, subscribe to our channel if you want to see more stuff like this. And yeah, go show some Real Engineering some love as well. Bye-bye.